Before water enters or re-enters the distribution system, it needs to be filtered and purified, removing the contaminants from it, enabling it to be fit for human use. But what are the use of this, and how do they work? Well, the general principle with water purification, at least on an industrial scale, is to start big and work down to the smaller items. This means that the first step is to screen the water physically for any debris in the water. This can be done by passing the water through a fine metal mesh or something similar. This, however, won't remove the smaller particles suspended in the water. For this, a range of possible chemicals are added to the water, like aluminium sulfate. These chemicals cause a reaction in the suspended particles, causing them to clump together. And these clumps will, when given time in a sedimentation tank, fall to the bottom of the tank, where they can be removed from the water. To remove any particles that have not settled out, air is blown through the water. This is especially effective at removing algae from the water. The final stages of the filtering process are similar to those in small household water filters. It involves passing the water through a layer of sand, which also has a layer of activated carbon. The source of the carbon is normally charcoal. The sand physically blocks the passage of the remaining particles in the water, but will eventually become clogged. It needs to be washed clean of the impurities by reversing the flow of the water and then removing the debris. The carbon, due to its structure, has a massive surface area compared to its volume, meaning if you had a ton of activated carbon, it would have an active surface area of over 300 square miles. Chemical reactions with substances suspended in the water take place over this large area, moving things like benzene, oils, and many items which either make the water taste bad or smell bad. In order to complete the process, now moved on to membrane filtration, where the water is passed through an ultrafine material to remove protozoa and other tiny life forms still remaining in the water, which, if left behind, may cause things like diarrhea. Once this is complete, the water now has no visible impurities in it and smells and tastes as it should. However, there may still be items in the water which make it unsuitable for drinking. Some of these, like phosphates and nitrates, are extremely difficult to remove from the water, which is why the overuse of fertilisers on farms can cause problems with the water supply. Other items such as lead, zinc, mercury, arsenic can be removed by a process called ion exchange. Finally, the water has no harmful bacteria in it. You need to add chlorine or some other thing to disinfect the water and keep it fresh on its journey to the consumer. This will prevent things like cholera and salmonella, a wide range of other life-threatening diseases being carried in the water. Because water coming out of the tap will still contain chlorine, it shouldn't be used directly for filling a fish tank, as you're likely to kill the fish. Depending on the water and where you live, two other processes may be used in water treatment. Fluoride may be added to water in an attempt to prevent tooth decay, and if the water has a high level of calcium carbonate in it, the water may be softened before distribution to prevent limescale building up on heating elements like kettles. As you can see, a lot of processes have to be used to make the water fit for use. Try not to waste it.